So last week for 4th grade, we are going to work on measurement and data with geometry. Here is a list of the standards that we will cover with measurement and data for 4th grade. Mr. Bacon asked the students in his 4th grade class to measure their heights. Here are some of the heights they recorded. List the 4 students from tallest to shortest. I want you to pause the video and do this for me, please. It doesn't matter how you tackle it, just work through something. Coming back to the problem, did you convert the heights? Maybe you guessed. Did you grab a yardstick? Did you make some kind of number line to compare? Well, how can we make sure who is taller between yards and feet? I will convert them all to inches. However, there is an unlimited number of ways to order them. You could convert them all to yards, all to feet and inches, and then do your comparison. Sarah is 50 inches, so she's already converted to inches. So now I'm going to work on Jake. We know there are 12 inches in 1 foot, so 4 1/4 foot would then be 4 feet times 12 inches plus 1/4 of a foot times 12 inches. And 4 times 12 is 48. 12 copies of 1/4 is 12/4, which we know is the same as 3, so 48 plus 3 is 51 inches. Andy is 1½ yards. We know there are 3 feet in 1 yard, so I will convert 1½ yards. So I decomposed 1½ into 1½, each multiplying them by 3. So 1 times 3 is 3, half times 3 is 3 copies of 1/2, which is equal to 3 plus 1 whole plus a half, which is 4½ feet. Now I need to convert that 4½ feet into inches. Again, 12 inches is 1 foot. So I decompose one more time. 4 times 12 plus a half times 12 is 48 plus 12 copies of 1/2 equals 48 plus 6, which is 54 inches. Finally, Emily is 4 feet and 4 inches, 12 inches in 1 foot. Part of it is already converted to inches for us, so I just need to convert the 4 feet times 12 inches and then add the 4 inches that are there. So 48 plus 4 is 52 inches. Now that they're all in inches, I can order them from tallest to shortest. So I see that it would be Andy, Emily, Jake, and Sarah. Maggie bought 3 apples that cost 50 cents each. She paid with a $5 bill. How much change did Maggie receive? There are a few ways we could tackle this problem depending upon what you would classify as the unit. We could do using the cents as a unit, using the dollar as a unit, or simply using decimals. We'll go through each one. So using the cents as a unit, apples are 50 cents each. 3 times 50 is 150 cents. $1 is 100 cents. So if she has $5, we have 5 copies of 100, which is 500 cents. I can build a bar diagram. I know that in total there are 500 cents. I have 150 cents for each apple that I paid. How much in blue is left over? 500 minus 150 is 350 cents, which is $3.50. Using the dollar as a unit, apples are 50 cents each, half of $1. 3 apples then cost $1.50. We can set up the exact same bar diagram, except our units are a little different. Because 5 is the unit, we have 1.5 that we purchased. How much is left? Well, 5 minus $1.50 gives us $3.50, or $3.50. Finally, using decimals, 50 cents is the same as 0.5 or 50 hundredths dollars. 3 apples is $1.50. 5 minus $1.50. We take away $1, that would leave Maggie with $4, and taking away an additional 50 cents means she will get $3.50 back. How are the following alike and how are they different? Pause the video, make some comments, suggestions. They both are an equation because they have an equal sign. They both have $12 times 4 or 4 times $12. They are different as one uses a letter and one uses a question mark. We're going to get away from using a box or question mark or blanks and fill them in with a letter or variable from here on out. Mathematical word problems can be written as an equation with numbers, letters, operations, and an equal sign. We can represent problems using equations with letters standing for the unknown quantity. So instead again of using a blank space, a box, or a question mark, they will now have a letter. Write an equation that would allow someone to find the value of S. Pause the video, see if you can't work this out. 50 milliliters plus 20 milliliters equals the whole value of S. So 5 plus 20 is S. Use a model and write the equation of the following statement. A monkey eats 3 pounds of bananas a day. How many pounds of bananas will the monkey eat in 5 days? Well, if he does 3 pounds a day times 5 days, I need 5 copies of 3 pounds. And then altogether, that would be how many bananas he ate. So our equation would be 5 copies of 3 or 3 copies of 5 equals B. Your favorite aunt is coming to visit your house next week. She's coming from Phoenix, Arizona to Fort Wayne, Indiana. She has to stop in Chicago and change planes. The total distance from Phoenix to Fort Wayne is 1,825 miles. On her flight to Chicago, she travels 1,754 miles. How many more miles does she need to travel? So use a model and write the equation of the following statement. We don't know how much she has left to travel, but we do know that she's already traveled 1,754 miles for a total of 1,825 miles. So the n represents how much further she needs to travel. So our equation is what she needs to travel n plus how much she's already traveled for a total distance of 1,825. So use a model and write equation for the statement. While helping with the laundry, JP found 13 nickels in a pair of pants and 6 quarters in a jacket. How much money did JP find? Well, we know that 13 nickels is the same as 65 cents. 6 quarters is the same as $1.50. So how much money did they find altogether? Well, we would need to add the nickels plus the quarters for the total amount of money that we have. Grade 6, 4, 5, and 6 celebrate the last day of school together. Each grade receives 20 gallons of fruit punch. If there are 425 students, will there be enough fruit punch for every student to have 2 cups? The teachers decide to make this a fancy celebration and plan to serve the punch in 19-quart decorative containers. How many containers will each grade need? Should be quart. Okay. From previous lessons, we already know how to solve multi-step word problems involving adding, subtracting, multiplying, division. Let's apply these while we're working with measurement. We know that there are 3 grades. Each grade receives 20 gallons. There are 425 students. Our goal is that each student gets 2 cups. 3 grades times 20 gallons means that we need 3 copies of 20, so 60 gallons altogether. How many cups is that 60 gallons then? Well, 1 gallon is 16 cups. So I can take 60 gallons times 16 cups for a total of 960 cups. But we also need to know how many cups we need for our students. So if I have 425 students, each student getting 2 cups, I get 850 cups is what we need. So yes, since 850 what we need is less than how many we will have, we certainly will have the ability to have each student have 2 cups. Further, we also need to talk about how many decorative containers we need. So I need to know how many quarts there are. Well, there are 4 quarts in 1 gallon, but we have 60 gallons times 4 quarts. So altogether, we have 240 quarts of juice. We need to divide that by 19 to determine how many containers that we need. So 240 divided by 19. Using our partial quotient, we can know that 19 times 10 is 190. So when we subtract, we have 50. 19 times 2 is 38, leaving me with 12 left over. As a reminder, I take the pieces that we multiplied 19 by, add them together, and that is our division, or our result. So we will need 12 with 12 left over, so we'll have 12 quarts left over. Aha! So we will need to upgrade to 13 containers for the 3 grade levels so that all of the juice fits in a container. Maya read for 1 hour and 23 minutes each day for 5 days. If it took her 4 minutes to read each page, how many pages did she read in the 5 days? Well, I know that 1 hour is 60 minutes. So if I have 1 hour and 23 minutes, that would be 60 minutes plus 23 minutes, so 83 minutes per day. But she did this for 5 days. So we can still use our area model, breaking and decomposing 83 into tens and ones. So 5 times 80 is 400. 5 times 3 is 15. So 400 plus 15 is 415. So she read 415 minutes in 5 days. But it took her 4 minutes to read each page. So 415 minutes divided by 4 minutes per page equals how many pages? Again, using our partial quotient, I can take 4 times 100 to get 400, leaving us with 15 left over. 4 times 3 is 12, with 3 left over. So 100 plus 3 is 103. Maya read 103 pages.
Mr. Fun is trying to program a robot to travel in a triangular path. Here is his program, and let's determine if it will accomplish the goal. Use models to show your thinking. Forward, right turn, forward, right turn, forward, right turn. So we need to have a starting point, and we need to go forward 3 feet. So let's assume that the distance from those 2 points is 3 feet in proportion to how actual the size it is. We then need to take a right turn 120 degrees and go another 3 feet. We need to take another right turn at 120 degrees and go 3 feet and make 120 degrees at our next spot. When I look at my protractor here, if I were to rotate it and place it on my triangle and line up, rotate it a little bit here, kind of make it see-through for us, I can see that the degrees are 120 degrees since we have to line our straight line up here and go 120 degrees this way. So this angle here is 120 degrees. We can deduce that there are 360 degrees in a triangle since all of their angles add up to 360 degrees. He's also trying to program a robot to travel in a square path. Here is the program. Will it accomplish the goal? So we need a starting point. we need to go forward 30 centimeters, take a right 90-degree turn, forward 30 centimeters, right 90-degree turn, forward 30 centimeters, and right 90-degree turn. We know that, first of all, a square has all sides that are equal. We also can deduce now that there are 360 degrees in a square, since if we add all of their angles together, 90 plus 90 plus 90 plus 90 will give us 360 degrees. If a circle has sections that equal 1/4 of the whole and 1/8 of the whole that are shaded, how many degrees would the angle form in the unshaded section measure? So we first start with a circle. I'm going to separate it into 8 parts. Because remember, when we want to compare, I can compare 1/4 and 1/8 in terms of 1/8 units. We know that there are 360 degrees in a full circle. However, we have divided our circle into eighths. So we need to determine how many degrees are in each section. So I'm going to take 360 and divide it by 8 using our partial quotients. Well, 320 is 8 times 40. When I subtract, I have 40 left, which I know is 8 times 5, so I'll have a remainder of 0. Remember, we add up the parts that we multiply 8 by, so it's 45. So each eighth is 45 degrees. The shaded portions are 1/4, which we know is the same as 2 copies of 1/8, and 1/8 for a total of 3 copies of 1/8, which are shaded. Let's let the plus signs there indicate the parts that are shaded, which means there are 5 copies of 1/8 which are not shaded. So 5 times 45 degrees, going ahead and decomposing our numbers. So 5 times the tens, which is 40, plus 5 times the ones, which is 5, 200 plus 25 is 225 degrees. Let's expand this into an application problem. Daniel was so excited to go on the Ferris wheel until it stopped moving. Let's help his teacher decide how far Daniel got so that he can fix. Daniel's green carriage moved to the position of the yellow carriage when it got stuck. In order to get the Ferris wheel running, the operator needs to know how much the carriage has moved. How could we determine how far the carriage moved? Well, this is a circle, and a full circle rotates 360 degrees. Danielle has moved 3 carriage spots, and there are 12 carriages altogether. I will take 360 degrees and divide it by the 12 different sections that our circle is made up of, which is 30 degrees. So each section is worth 30 degrees. And since he moved 3 of those spots, 3 times 30 gives us 90. So Daniel moved 90 degrees from his original spot. The rotation of an angle is measured in degrees. An angle is created when 2 rays intersect at a single vertex. The size of the angle is measured in degrees. Angle B measures 55 degrees. We are trying to decide if the measure of angle A is greater, the same, or less. What do you think? Angle A is larger since its rotation is larger than angle B. Moving on to geometry. We need to be able to draw points, lines, line segments, classify 2D figures based on parallel or perpendicular lines, and recognize lines of symmetry. Walking through town, you look at your map and notice many things learned in math class. Take a moment to pause and identify the geometric figures that you see. I see many things. I see squares, I see semicircles, I see triangles, I see rectangles, I see circles, amongst other things. We can also see angles all over town. So I've circled them in red. And further, we also can see parallel and perpendicular lines. I've circled them as well. While walking around town, you take a bunch of photos and you want to organize your images based upon the pictures. How might you group them? You can identify points, line segments, lines, rays, and angles. Geometric figures can be made from lines and line segments. So you may have grouped them by sorting by color, such as yellow, brown, or any other color that you see. You could sort them by shape, such as circle, rectangle, and parallelogram. Or we could sort them by parallel or perpendicular lines. Two lines are parallel if they are on the same plane and will never intersect, and perpendicular if they are on the same plane and intersect to create right angles. Parallel lines must remain equal distance apart, such as the blue lines listed, and perpendicular lines must create 4 right angles. Let's look at the letters MATH. Use the vocabulary words intersect, parallel, and/or perpendicular to describe the lines that make up the letters. The letters T and H have perpendicular lines. The letters M and H have parallel lines. Only intersecting lines that are not parallel nor perpendicular are contained within letter A. We know how to classify triangles based on its angle measurements, but what about lines of symmetry in triangles? Take a moment to draw the lines of symmetry on this triangle. I can see that I can use each one of its vertex to draw a nice line of symmetry where if I were to fold on that line, I would get the same shape on both sides. Notice that all 3 angles are the same. They're all the same. They're equal. And we have 3 lines of symmetry. Draw lines of symmetry on this triangle. I can draw a line of symmetry down the top, from the top vertex through the bottom. However, if I were to draw a line from this vertex across, if I were to fold that, it wouldn't quite be what it should be to fold it because it wouldn't be the same shape. This triangle only has 2 equal angles. These are the equal angles here and here, and that we only have 1 line of symmetry. What about this green triangle? I don't think I can draw a line going from this vertex down, or this vertex across, or this vertex across. Notice that we have no equal angles and no lines of symmetry. Lines of symmetry can be used to create mirror images in figures. A line of symmetry that divides a figure into 2 congruent figures, each of which is the mirror image of the other.